Alright, so this is my demo. So first, let's show the structure of all of these classes. So let's open them up. Okay, so starting with requestChannel.h. So this class was made by taking everything that was common to all the request channels and everything that they need. So any enumerations, names, the write and read file descriptors, and streams, as well as some methods like constructors and cread, cwrite. All of these things, all of the different types of channels like FIFO, message queue, they're all going to inherit these methods. So since they all have these methods, they're all in this parent class. So next would be the FIFO channel. So the FIFO channel just implements all of the virtual methods, and there's not a lot changed in it. So yeah, I don't think anything in here changed from the starter code, besides taking everything out of what was originally in this class. But for the message queue, let's pull up the page. So the header file looks pretty much the same. It's just implementing those inherited methods, but it's different this time. So you set the file descriptors to the right stream or pipe, which is done right here. So it's going to return the FD, which this time it uses message queue open, and it is attached with these attributes to make sure that there aren't too many files open and the message size is correct. And it looks pretty similar to the standard definition that was in FIFO. But you do have to do the MQ specific methods, and for some reason it doesn't work without the slash. So let's continue on. So the SMH is the different one. It's much different than the other ones because you have to have this SMHQ class, which has the implementation for how the shared memory is actually going to work and receive and everything like that. So this class creates a memory segment, and then it uses the semaphores, and it uses that to keep the synchronization of the two streams intact, so that you don't read before you write, the client doesn't start before the server, kind of thing. And the send and receive just sync up, and then they do all the memory copy that they need, and then they will send a message to their counterparts to let them know to update their semaphore. So let's go into the other classes. So let's start with client.cpp. Okay, so the main thing that was changed in this class was the support for new channels as well as different types of channels. So that's why these two variables are created, as well as these cases, like case I, is to handle the new arguments. So, as well as this line right here. And then you pass the new arguments, so the server is also going to need the type of channel. And then, based on the type of channel, then you're going to create your channel using the classes that were created. So if they want FIFO, you make FIFO, and so on. And other things I changed were I moved a lot of variables outside of the for loops and the ifs so that they can stay in scope. And one thing I changed was that the out file is opened before the channels start really getting operated on, because we're opening so many new channels. If a file gets opened and then closed, if they're all doing it at the same time, it can cause some permission issues and some files can get locked. So instead, the file opens before all of the operations start and then it closes afterwards. And then we also have some timing mechanisms here. So I created a for loop that will run for the number of channels, and it'll create the new channels, assign them to the not control channel, and then it'll start doing these operations. So first, for the retrieving the data points, the thing I changed was each channel is going to split up the data points between them. So if there's 5 channels for 1,000 data points, each channel will read 200 bytes worth of memory. So that's what this for loop achieves. It segments the section of the data for each channel. So the first channel will only go from 0 to 200 and so on. So next is the file transfers. So the main thing that was changed here is right this section. So the actual size of what you're going to be writing, as well as the offset of the file, were the things that need to change. Because if you're trying to split the data up among channels, then each channel is going to need to get a portion of the data. So instead of defining just the portion that you're going to be writing as the entire file size, you split it up using these algorithms. And then the offset is changed in a similar way to line up with the partitions of the data. So I think that was, oh, that's right. So there's also some deletion because new channels are being created. So this line says if it's not the last channel, then you can go ahead and delete it. But I left the last channel because this line, when it's checking the control channel to quit, needs this channel to still exist. So instead of deleting all of them here, I just waited until the very end to delete the last channel. And then you wait for the server. So I think that's the overview of all the changes I made. So let's start getting these. Let's start doing the demo. So let's split this. Okay. So let's see, terminal. Okay. Oh, that's right, server CPP. So the server, not a lot changed. Pretty much the only thing that changed was the creation of different types of channels based on the IPC method. So that happens in the process new channel request and in the main method. But I'm pretty sure, other than that, nothing else changed in here. So let's do this now. All right. So let's do client-p 10 e1-c 5-f. All right. So we have the time elapse there, and then we also have, as the program continues, it'll exit and delete the channel that it just used and start a new channel because it splits up the data between the channels. So let's do that, but with the queue. Oops, that's not queue. Queue instead. Yep. So there's the time lapse there, and then so let's do ls. Yeah, so as you can see, nothing's left over, all the queues are getting deleted. So let's do the shared memory, which is S. All right, so same thing, and then we can check the directory, which is SHM, I think. What is that? Alright, well, I'm not actually sure what those are, but they don't look like the other SMH things that I saw in there. But we'll continue on. So let's see. So run the following to request. Okay, let's do that. So truncate -s 10000000. Oh, it's not in the right directory. So let me copy that over into the proper directory. There we go. Okay, so let's do that again. All right, so created 50 channels. Yeah, so it goes through all the different channels, and you can see how it partitioned it. So it's writing 20,000 bytes per channel. So let's, oh, that's right. And then I gotta do if receive /1 .dat bindc/1. Did I misspell that? I did misspell that. There we go. No response, so we're good. Then we can do, let's see. Oh, so F requesting to 23 channels. All right, there you go. Creates 23 different channels, and then we can run this again. Same, so let's do Q and 50. There we go. So let's do, what's that? Is that F and 35? Okay. Alright, and then we can do, so my SHM is set to S. That's according to the handouts. So let's do a 50 right here. Alright, and then it says 19 and F. Oh, that's right, I need to run the difference. There you go. Okay, so 19. I don't know if this should be F or S, but I'll just run both. So, okay. There we go. So, also pull your code to show that you split the file through these channels. Well, I can attempt to go over that a little bit here. So how it actually splits it is that this for loop runs from I to N channels, and then all the way down where you're setting how much you're going to write to, it So for